Okay, today we're going to do sections 1.1 and 1.4. At this time, I don't see any others that have joined me for this. 1.4 is dealing with a different topic. Our first definition, principal square root. The principal square root is a positive square root. So if I write down the square root of 25, you only give me the answer of 5. Principal square root. Notice that I got a little note right here, and I just sent you an email to back up this. Your first quiz is due Monday night. We have to have it done by 11 o'clock. We've already covered all sections 1, 2, and 3, which is what the quiz covers. You can do that anytime between now and then. You can have more than one try at it. The computer will automatically keep your highest score. Back up a little bit about square roots. Let's go back to what we had the other section. The square root of a negative 36, you're going to give me 6i, the principal square root of 6i. Now, be careful. If I ask for the cube root of minus 8, the cube root of minus 8 does not have an I in it. The cube root of minus 8 is negative 2. So the odd root of any negative number is going to be negative. Certainly the odd root of any positive number is going to be positive. Just be careful when you're taking an odd root, you don't introduce the I because it's not there. The first problem that you have in your homework goes like this. 51x cubed plus 17x squared, and they simply say factor. Well, it doesn't look like much factoring, but all you can do here is take out the common factor, and you can take out the common factor of 17x squared. 17 goes into 51 3 times. X cubed divided by x squared gives me x to the first, and then 17 and the x squared is canceled, and it gives me 1. So this is the factored form of this, and you have one like this in your homework. Now, notice up here that we give you an extra word, a new definition, an extraneous root. An extraneous root simply means that it is an extra root. Today, we're going to be dealing with what we call radical equations. So let's take the first problem. Square root of 3 minus 2x is equal to x. So it's a radical equation simply because we have the radical in it. To get rid of a radical, you square both sides. So that means I'm going to have to copy this thing down again. And I'm going to square both sides. Now, when you square a square root, it simply takes the radical off. So on the left side, we have 3 minus 2x is equal to x squared. Well, this goes back to the second section that we covered. This is a radical equation. Quadratic equation, we had 4 methods to solve it. We can factor, square root method, complete the square, or we can use the quadratic formula. And in this case, since the positive x squared is on the right side, I'm going to move everything to the right side. Now, it's very convenient for us to factor this, and it factors into x and x. The only factors are 3 or 3 and 1. The positive sign in the middle says that the biggest product has to be positive. The negative sign on the back end says that this has to be negative. So I make me 2 linear equations out of it. X plus 3 is equal to 0, and x minus 1 is equal to 0. So x is minus 3, and x is equal to plus 1. Now, very, very important. You must check. Every time you solve a radical equation, you have to check it because you have the possibility of that extraneous root that we just defined up there. Let's put in the 1. If I put in the 1 in the original problem, 2 times 1 is 2, 3 minus 2 is 1. The square root of 1 is 1, And on the right side, we have a 1. So the 1 checks. But watch what happens when we plug into -3. I plug into -3, and this gives me -2 times -3, which is a +6. 6 plus 3 is 9. Now, we've just made a big definition, principal square root. The square root of 9 is 3. On the right-hand side, when you plug in the x, you're going to get a -3. Well, 3 is not equal to -3. So we can't use the x is equal to -3. That is our extraneous root. I repeat, every time you solve a radical equation, you have to check all your answers to see which one works. Let's step it up just a little bit. And notice this time, the radical is not by itself. So the first step we take is to get the radical by itself. 3x plus 1, bring the 3 over. Now we're ready to square both sides. Square the left-hand side is easy. It simply takes away the radical, 3x plus 1. Squaring the right-hand side. Squaring a binomial that does have a shortcut. My recommendation is simply put it down and FOIL it. When you square it, you're multiplying it by itself. So you got 3x plus 1 is x squared. Good morning, Alexandria. Minus 6x plus 9. Alexandra, can you hear me? So 0 is equal to x squared minus 9x plus 8. Again, we're lucky because this thing will factor. In fact, I would suspect that all of them that we work are going to factor because we don't want to get that complicated with our answers. Since the middle sign is negative and the tail end sign is positive, both of these have to be negative because a negative times a negative gives me the positive. We make our two linear equations. So this says that x is 8, and this says that x is equal to 1. Okay, let's try it again. Let's check the 1. We put in the 1. 3 times 1 is 3, plus 1 is 4. The square root of 4 is 2. 3 plus 2 is 5. We put in the 1 on the right-hand side, and we get 1. 5 is not equal to 1. Therefore, we have to exclude 1. Even though it showed it as an answer, it's an extraneous root. Let's try the 8. 3 times 8 is 24. Plus 1 is 25. Square root of 25 is 5. 5 plus 3 is 8. On the right-hand side, we've got 8. Therefore, the 8 checks us. I repeat, when you work a radical equation, you have to check all your answers because you don't know which one. I'm going to say a very difficult one until last and see if we have time. If we don't have time, we're not going to worry about it. Meantime, let's back up and let's work a problem like we worked the other day. And this is the fourth degree equation. Fourth degree equation says that I'm supposed to get 4 different answers. We're fortunate this thing factors into x squared and x squared. 36 has many factors. 9 times 4, 12 times 3, 18 times 2. But 36 and 1 is what we're going to use for this time because 36 and 1 will add to give me that 37 in the middle term. Since this is negative, both of these signs have to be negative. Now, this time, when we make our equations, they are still quadratic. There are 2 ways to work these problems. I think that you need to use that very simple method of the square root method. You take the square root of both sides and you get plus or minus 6. On this one right here, you get x squared is 1. You take the square root of both sides and you get plus or minus 1. We worked a problem very similar to that the other day. In fact, it might have been the same numbers. Now for a different topic. We've just worked radical equations. Course Compass is going to force you to work a couple of these things by something we call the substitution method. Okay. Using the substitution method, we're going to let some letter, and he uses U, so I'll use U. And what you do, whatever looks bad in the middle term, that's what you substitute. So in this case, the x minus 2 is what's making the problem. So we're going to let U be x minus 2. When you do that, rewrite the problem. So now you've got 9u squared minus 26u. And then we're going to bring this 3 over and then make it equal to 0. Look at it again. We let u be x minus 2. So over here you had x minus 2 squared. In the middle, you had x minus 2 to the first power. Forget where that came from, but look at it. This is the quadratic. This is second degree in u. Now, this is what's tough because we didn't factor many of them where the a term was other than 1. In this case, the a term is 9. We can try 3 and 3, that won't work. So we're going to use 9 times 1. 9 times 1 is going to give me that 9u squared. The tail end number, I've got 3 and 1. Well, I'm going to put the 3 here and I'm going to put the 1 here. And we're going to see why, because let's look at this product. This outside product would give me 27u. This inside product would give me 1u. Out of 27 and 1, I can get my 26. The same rule still applies. The negative sign in the middle here has to go with the biggest product. The biggest product is the 27. So that means that the negative has to be with the 3, and that would say that this one would have to be with the 1. We still got work to do. This time, my reduced things are both linear, but they still have the u in them, and they still don't have the x in it. So you're going to have to resubstitute, and in place of the u, we're going to put this x minus 2 that we just used. After distribute, I get 9x minus 18 plus 1 is 0. I get 9x minus 17 is 0. 9x is 17. X is 17 divided by 9. Thank goodness we don't have to check these. Checking 17 divided by 9 would be a pain. And the other one, the u, x minus 2 minus 3 is 0. So I got x minus 5 is 0. So I got x is equal to 5. Solving by substitution. You have one like that in your homework, and I think you might have one like that on the next quiz. I'm not sure. Remember the other day I said, always look for common factor. Here's a real good example of that. X cubed minus 25x. We can take out the common factor of x. So if I take out x, I have x squared minus 25 is equal to 0. Well, x squared minus 25 factors into x plus 5, x minus 5. So I get three answers. X is 0, x is minus 5, and x is plus 5. Once more, you don't have to worry about checking these because it's not a radical equation. These three answers, all three of them will work. Okay. If you took Algebra 2, and I'm pretty sure you covered problems like this in Algebra 2, this is a different kind of factoring. We're going to work this problem by factoring, by grouping. And I'm going to say in this course, because of 99% of the time, you're going to group them 2 by 2. The first thing you do is make sure they're in the right order. I have x cubed, x squared, x to the first, and then no x. You need to put them in descending powers before you start the factory. I just got through saying we're going to group them 2 by 2. So I'm going to take these 2 and these 2. Out of the first 2, I can take an x squared. I take an x squared, and I have x minus 3. Now, this is the key to it. What I've got left here is x minus 3. I want to end up with an x minus 3 here. So to do that, I'm not going to take out just a 9. I'm going to take out a minus 9. Minus 9 into minus 9x leaves me a positive 1x. 27 divided by minus 9 gives me minus 3. Now look at it. Each of these things have an x minus 3 in it. So I'm going to take out the x minus 3. When I divide it out here, I have x squared left. And when I divide it here, I have minus 9 left. This is a unique problem because of the way these answers are going to come out. We could do it the other way, but let's just follow through with what we've got. X squared minus 9 is the difference of 2 squares. It will factor into x plus 3 and x minus 3. So it's kind of crazy what we get. Welcome back, Alexandria. I hope you can hang around this time. So I get x is 3, I get x is minus 3, and I get x is 3 once more. So I have repeated answers on this one, and I think when you write this down for Course Compass, they're going to require that you write it with the repeated answer. In other words, write the 3 down twice and then put the minus 3 down. Alexander, can you hear me?
Yes, sir.
Good enough. Hang with me if you don't mind. In fact, I'd like for you to keep it like it is. Don't turn your video on. Just keep your audio on. I think that the video is what used up our megabytes on the last trial when we did this, and it was too big to upload. We're going to give that a try and see, okay?
All right, sounds good.
All right, good. Since you just got here, let me go back through this problem with you because this is a different topic and people have hassle with this. It's been a long time since we did it.
Okay.
Look at the original problem. X cubed minus 3x squared minus 9x plus 27. We're going to use a method called grouping. Do you ever remember doing that?
Yeah, I do.
Good. You had a good Algebra 2 teacher then, or maybe advanced math you took it. The idea with grouping, in our case, we're going to group the first 2 and the last 2. So I take the first 2 and I take out an x squared. It leaves me an x minus 3. I take the last 2 and I take out a minus 9. And the reason I take out the minus 9 is because 27 divided by minus 9 is going to give me this minus 3. And that's the same minus 3 that I got over here that I need, okay?
Yes, sir.
Now, and then look at it. I can take an x minus 3 out of each one of those. And in the first case, it's going to give me x squared. In the second case, it's going to give me minus 9. Now, this one is unique. X squared minus 9 is the difference of 2 squares. We can factor it into x plus 3 and x minus 3. So when we set all this up, we get 3 different answers. X is 3, x is minus 3, and x is 3 again. it's perfectly legal to have repeated answers. In other words, I can have the 3 twice for an answer. Okay, I had saved one. You wasn't here when I made that statement. This thing is very time consuming. Let me make sure I copy it down right. I got the square root 3x plus 1 minus the square root of x minus 1, and that's equal to 2.
Okay.
Okay, this time it's different. Since you weren't here for the first part of the section, you're supposed to get the radical by itself. Well, what makes this one difficult is that we got 2 radicals. So we're going to have to isolate the radical. I'm going to take the radical with the 3x plus 1 and keep it on the left side. I'm going to move the other one to the right side. Fair enough?
Yes, sir.
Okay. Now, the deal is this. Once you get this done, you're supposed to square both sides. Well, squaring the left side is a piece of cake because when I square a square root, it simply removes the radical. So the left side is going to be 3x plus 1. Now, my recommendation is this. On the right side, it simply means that we're multiplying the right side by itself. So we're going to put it down as square root of x minus 1 plus 2 times the square root of x minus 1 plus 2. Now we're going to be super careful when we're doing this multiplication. So all we're going to do is FOIL it. The left side, we just let hang around, it follows. Now, the square root of x minus 1 times the square root of x minus 1 takes away the radical. It's just x minus 1. Do you buy that?
Yes, sir.
All right. Now, the outside product is going to be 2 times the square root of x minus 1. The inside product is also 2 times the square root of x minus 1. And then the last product is going to be 4. So what we did is FOIL this mess, just keeping that square root like it was a single term. We still followed the same step. First term multiplied, outside, inside, and then last. Now we clean up our mess a little bit. So I got 3x plus 1. And over here, I don't have anything else to go with that x. And I got 2 times that plus 2 times that is 4 times x minus 1. And I got minus 1 plus 4, which gives me plus 3. Agreed?
Yep.
All right. Now, we clean up this mess. So this is going to give me 3x. And this gives me plus 1 minus 3 is equal to, oh, I didn't bring it both over. I'll go ahead and bring it over now. I got an x to bring over also. This gives me 4 times x minus 1. Now let's clean up the mess on the left side. Keep me straight when I don't have it pushed up far enough for you to see, holler at me, okay?
Okay.
3x minus x is going to give me 2x. 1 minus 3 is minus 2. And on the right side, I got 4 times x minus 1. Fair enough?
Yes, sir. That's a x minus 1 under the
radical, right.
Yeah.
Okay. Now, we're going to be kind to ourselves. Look at this. I got a 2, a 2, and a 4. Let's divide everything by 2. So I get x minus 1 is 2 times radical x minus 1. Fair enough?
Yes, sir.
All right. Now, we're ready to square both sides again. So I square this side. I square this side. I square this side. I'm going to get x squared minus 2x plus 1. I square this side. I get 4 times x minus 1. So this is going to give me x squared minus 2x plus 1 is 4x minus 4. So I got x squared minus 6x plus 5 is 0. And I'll be honest with you, I always hold my breath until I get there, because if this would have come out quadratics that won't factor, it would make our problem very, very difficult. But we got very lucky. The only factors of 5 are 5 and 1, correct?
Yes, sir.
Now, and I have to have both of them negative, because this is going to be a negative here. So I get 2 answers. X is equal to 5 and X is equal to 1. Now, I made a big deal out of this when I started this mess. When you have a radical equation, you have to check your answers. So let's do the easy one first. Let's try the 1. We come back to the 1 and we put it up here in the top. 3 times 1 is 3, plus 1 is 4, and the square root of 4 is 2. Over here, 1 minus 1 is 0, the square root of 0 is 0. And 2 minus 0 is 2. So the 1 checks. I think both of them may check. Let's try the 5.
Okay.
3 times 5 is 15, plus 1 is 16. Well, that's going to give me a 4. And then over here, I've got 5 minus 1, which is 4, and the square root of 4 is 2. And lo and behold, 4 minus 2 is 2. Correct?
Got it.
All right. So we got to the hard one. Now, I'm going to have to do something a little bit different, Alexander, because as I said, I don't want to have to redo this thing twice. And that's what I had to do yesterday. I had to just go back and by myself make that video. By the way, did you get to view the video that I posted?
I did view the video for 1.3.
Yeah. Did it work?
Yes, sir.
All right, good. Then that means it's going to work. So what we're going to do now is we're going to take a 5-minute break. I'm going to stop this thing. I have to have that much time to download it before I start with the next section. Come back to me in 5 minutes.
Okay.
All right, good luck.
Thanks.